Well, good morning, everyone, and then welcome to the Balanced Mixed Design Implementation Planning webinar. Plan ahead, succeed ahead. Today, our two speakers are Tim Aschenbrenner from the FHWA Office of Infrastructure at the headquarters, as well as Derek Nienerplant from the FHWA Resource Center. We're gonna start with some housekeeping item. If we can go to the next slide, please, Tim. So please, during the webinar, make sure your microphone is muted, and feel free to post your questions in the chat box. At any time during the webinar, I will go through the questions and organize them, and then by the end of the presentations from our speakers today, they will get a chance to answer those questions as time permits. And if there are any questions that remain unanswered due to the time constraints, we will respond to those questions separately. Also, this webinar is being recorded, and it will be made available at a later time, and it will be posted on the Western Regional Superpave Center website, the University of Nevada, Reno website, and then you'll get a chance basically to watch again the webinar. Now, this basically webinar today, it's about the implementation plan related to the balanced mixed design. And it's one of 5 webinars as part of the AIEI webinar series. You can see here the between today and early June, the different webinar timing, and then the title of those webinars. If you are interested, you can register by using those QR codes that you see over here, or if you basically check your chat box, you will see the PDF file similar to the one that you see here on the right-hand side, with the description of the webinars and the link to register for those webinars. Now, this is a disclaimer. So this is part of an effort that's being conducted in cooperations with the Federal Highway Administrations under the listed cooperative agreement that you see over here. And except for any statutes or regulations cited, the content of this presentation do not have the force and effect of law and are not meant to bind the public in any way. It is just intended to provide information to the public regarding the existing requirements under the law or agency policies. Also, the US government does not endorse products or manufacturers, so you may see some trademarks or manufacturers that may appear in this material, and that is only because they are considered essential to the objective of the material. And any reference to the AASHTO, ASTM, or any other standards in this presentation are voluntary standards and are not required under the federal law. Obviously, there will be some acronyms throughout the presentations, and then we have them here. The main ones are listed over here for your reference. Sometimes it may be hard to keep up with the acronyms, so I'll stop just for a few seconds here to give you a chance to go through them. Thank you. If we can move on to the next one. And then the expected outcomes for today's webinar. So we're going to be talking about the implementation plan for balanced mixed design. So it is critical to recognize how important it is to adopt and develop an implementation plan, as well identifying the key tasks that needs to be completed prior to creating that initial implementation plan. Hopefully, by the end of this presentation, you'll be able to understand how your available resources, whether you belong to an agencies or contractors, can influence the scope of the implementation plan, Also identify how key stakeholders can assess in the development of the implementation plan. And then finally, hopefully you'll get to learn about some of the effective practices from the lead states related to the BMD implementation plan. With that, I will pass it on to Tim Aschenbrenner to get us going on the presentation.
Well, thank you, Ellie. I'm going to start off and go over a little bit of the background. Derek is going to follow up and go over some actions prior to creating a plan. Then I'll pick up on implementation planning and provide examples from 3 state DOTs. And then Derek will wrap up with effective practices and lessons learned. So as we get started with the background, many state DOTs are selecting mechanical mixture performance tests to implement their balanced mix design. And these tests relate to distresses. Usually it's the type of distresses they commonly find in their state. This relates to rutting, cracking, moisture damage. Those are the 3 distresses that we see states picking tests for most often. Although we are seeing some states focus on frictional characteristics, such as the 3-wheel polishing test or durability, for example, the Cantabro. There are other tests. I think the common example there is related to cracking. Of course, there's top-down cracking, fatigue cracking, thermal cracking, reflective cracking. All those different types of cracking distresses associate with a different cracking test. So there's really no 1 or 2 tests that everybody uses. It's really up to each state to determine what's necessary for them. Now to keep track of where people are at and some of the common mechanical mixture performance tests being used, we rely on NAPA's Balanced Mix Design Resource Guide. The link is there at the bottom of the screen. They keep this updated every quarter. The maps shown here were last accessed in October of 24, so the information really is up to date. If you see something that's not up to date, then certainly inform NAPA and they'll get that corrected. But the most common rutting test, the map there on the left, seems to be at this time the Hamburg wheel track test. There's about 22 states that are leaning in that direction. Not only does it do rutting, but it also gives an indication of moisture susceptibility as well. And then the map on the right shows the direction states are leaning towards in terms of cracking test. That's right now seems to be the ideal CT is the most popular. There's about 23 states looking at the ideal CT. On the NAPA Balanced Mix Design Resource Guide, they have other resources as well. This gives an idea of where state DOTs are in selecting their approach or where they are in implementation. And most states right now are in pre-implementation. Pre-implementation is a great place to be in terms of developing a plan for implementation. However, regardless where you are, it's never too late to start developing a plan. Now you'll see there are some approaches here that states have selected. And the one comment I would make there is you don't just want to get locked into one approach. You don't want to find your favorite parking lot and park there and stay there forever. You certainly want to advance, but of course advancing relies on confidence in the test. And to get that confidence that the test results match your field performance really relies on validation. And I bring that up because validation will be the topic of our next webinar series next month. And as we go through this information, we've gathered information from a variety of sources. Most notably, we looked at case studies from 7 lead states back in 2020. We virtually visited these 7 states. We looked at the information and specs in advance, and then we spent 2 to 4 days with each state to understand all the details of where they were at. Now, that was a little while ago, but we have kept things current. We've stayed in touch with these states to make sure we have the latest information. And a result of that were three key products. One is an individual state report. So each state has their own report. Then there's an overall summary report, and so that's one report that summarizes key information from all of the states. And then the tech brief, and the tech brief is critical in identifying those 8 tasks that we observed each of these states somewhat followed in terms of their implementation plan. So the tech brief and the other documents are at the links below. So with that, I'm going to turn it over to Derek, who's going to go over the actions prior to creating a plan.
Thanks, Tim, and thanks everybody for joining us today. Appreciate you joining us in the first of a couple on balanced mix design and getting closer to implementation and kind of addressing some of the common challenges. So again, as Tim kind of started walking us through, and Ellie as well, is that we are all about trying to get to a plan. So where are you starting in order to get to a place where you can actually make progress and succeed? So there's a couple actions that you want to think of before you get to actually creating a plan. And that's what I'll cover. And then Tim will come back and talk about some of the examples and what that plan actually looks like. And so what we'll kind of talk about is harkening back to what Federal Highway and others worked on, which is the tasks for BMD implementation. If you haven't seen this before, you can join the hundreds that have enjoyed this particular table and publication. But this is the kind of listing of tasks and subtasks we often talk about to get to BMD implementation. This was developed through the UNR co-op, also in cooperation with the National Center for Asphalt Technology, as they were working on something similar, with listed kind of the things that many need to accomplish in order to get to something that is implemented in the realm of balanced mix design. So for this particular webinar and where we're talking about what is typically put in task 2, overall planning. Makes sense, right? So what I want to cover is some of the things that get to before you can even get to the plan. What are some of those things you need to consider even before you get there? And so a big one that can't be underestimated is understanding, why are you changing? Why are you looking at balanced mix design in the first place? Why are you going to expend resources? And this is great advice that been taught time and time again, that change can be painful, change requires effort, and you need to know why if you really want it to succeed. So why change? Why do balanced mix design? So I think the obvious thing that we often hear is that many believe, number one, mixes behave differently, that within their state, within your agency, whatever it is, within your area, you have certain classifications of mixture. And whatever they are, class 1, class A, whatever it is, they all behave a little bit differently, right? Even though the specification says they're equivalent products. We also, many acknowledge that the current design procedures may not optimize performance. You know, in general, the pendulum shift that we went away from previous mixed design ideologies, we went to super pave. We got rid of rutting, we had cracking and more cracking, and that volumetrics alone is not optimizing our mixtures. So number one, you know, improving performance has got to be in there as a why. And give a couple examples of seeing the evidence of improved performance with balanced mix design and the potential for the future. Because as those working in the pavement world, we all know that if we get one more year on all of our treatments all of a sudden, right, from this year to next year, all of a sudden, every treatment we do gets one more year. Doesn't sound like a lot. It makes massive impacts to our transportation network. That even though that doesn't sound like a huge impact, it is. I'll show some evidence of that in a moment. So you've probably seen something similar to this slide many times. I think it's important to continue to bring up why change, because the things listed on this slide were really not considered in what we do now in standard super pave. So recycled asphalt shingles, those weren't really on the market or really used in asphalt mixtures at the time when super pave was developed. Fractionated wrap. Wrap was certainly around, but not pushed maybe to where we use it now, increased percentages or the use of fractionization. Modified binders, again, not to the degree that we have today with a number of modifiers, the highly modified materials, etc. Those binders weren't around when SuperPave was first developed. Fibers, additives, warm mix, the list goes on. There's a lot of new technologies that were not necessarily incorporated into our volumetric or our SuperPave analysis. So they're not really handled necessarily well in that system and need something that can account for their impact on performance and the mixture that will take that into account. So what about all the other kind of benefits, right? Certainly we want better performance. We want ways to incentivize better performing asphalt mixtures. Well, what else? A big one for many states is optimized use of recycled materials. We know that recycled materials can lead to more economic mixes. There can be savings there, all right? As it uses, asphalt that's already in those recycled materials or aggregate, et cetera, to help keep costs down, also reduce impacts in other places like emissions or other areas. But the idea being that a lot believe, and a lot of the work has shown, that SuperPave may be okay at a certain wrap content or recycled material usage, but beyond that, it starts to struggle. And it's in that struggling area that maybe balanced mix design can come in. So allowing more recycled material usage is one potential benefit that many agencies and contractors as well are looking at as a potential benefit. That goes into also local materials, utilization of more local materials. We know that resources are finite in a lot of places, be it aggregate, binder, etc. So if we can promote the use of local resources, maybe aggregate sources that are closer to the project, closer to your area, that may not only help in the economic side of things, but also in impact to the environment. All those things kind of put in together. It can also perhaps handle innovative materials. I know agencies a lot of times are approached by a new product, a new additive, a new way to put in asphalt mixtures, whatever it is. Today we talk a lot about recycling agents, warm mix asphalt, new binders may be off, bio binders, etc., modifiers. Those all, if you really look at the existing SuperPave system, a lot of it really isn't kind of handling how these new things are going to impact the mixture. If you look purely at volumetrics, air voids in the mineral aggregate, etc., that's not really encapsulated in that analysis. So is balanced mix design a way to say, no, I don't need to write an individual spec for your material, more of meet these kind of requirements, and I'm open to trying new innovative materials. And certainly, again, we can't hit it any harder, enhanced pavement performance, anything that extends pavement life, reducing that maintenance and rehabilitation need, it compounds. I'll show you an example of that in a moment, of that compounding effect, that 1 or 2 extra years in the right places where it's hard to impact traffic, right? All those kind of impacts are important. That really drives the point that even if it takes some work to get there, if we can get that improved performance, it's going to be worth the effort. So I have an example that we often cite if you've seen some of our BMD balanced mix design work before, but this is from the state of New Jersey. And this is from their pavement management network, right? Network analysis of their system. And it shows for the last 15 years, starting in 2022, take some time to do the analysis. And what you see, right, by looking at the bar charts here, is that the system was not doing great 15 years ago. Almost half or more than half, depending on the year, of the system lane miles in what they would call deficient condition, and very few in good. And we show this because when you ask New Jersey DOT, how did their condition improve? And that's what you're seeing from 2007 to 2022. Really, they flipped the script, right? They flipped from half deficient to half good, all right? And it's taken time, but they've gotten there. And when you ask them why, when you ask them how did they achieve this, how did you see this major improvement? There's no significant increase in funding. There's none of that. What they point to is that they started to use specialty asphalt mixtures with concepts that really were balanced mix design before we called it balanced mix design. So these are their mixtures that they use on some of their highest traffic locations, or in other cases, high wrap mixtures. And the backbone of those specifications are in mechanical mixture performance tests, balanced mix design, right? So some of their specifications even go to the point of, not necessarily specifying binder grade or something like that, and just saying meet these 3 tests for durability, for rutting resistance, etc. And they say in these 8 cases, in some of the roadways that have the highest traffic in the nation, they've seen significant life extension, right? There's a big difference on a major expressway up near New York City between getting 5 years and getting 10 years. And what you also notice in this chart is that it doesn't happen overnight, right? It didn't happen overnight. They didn't start at 2007, 2010. It's still not looking great, right? But you have this compounding effect of extended pavement life that starts to make significant gains over time. So may not show up right away, but it is significant in how their system has performed. Another thing on why change, this is just another example, an excellent example from the National Center for Asphalt Technology, NCAT, and their test track, where they have their sections that they perform and do traffic loading over the course of 2 to 3 years. And this is an example that they have from Texas mixes using and not using balanced mix design. Obviously, there's a lot of research that goes into this, but this shows essentially right what we're trying to get to is they have similar mixtures, right? One that was volumetric and then 2 that were designed with balanced mix design. Now, these still had to meet volumetric requirements, but still they adjusted the mix beyond what their typical specification would allow, right, a little bit, and got to meeting the sweet zone of an overlay test and a Hamburg wheel tracker. And what they found to date, right, if you go to the chart on the right, they're tracking, cracking, lane cracking via the easels that they've loaded. And essentially, the sections, the volumetric one, S11 shown here, is started showing cracking, right, and got to 14, 15 million easels, and they hit a certain criteria, right? The other 2 BMD mixes, one has been out there for the same amount of time. It has less than half of the cracking that the other section has, and has kind of plateaued a little bit. Another one is in a newer cycle, the newer N6, all right? But N6 has no cracking after 10 or 9 million easels so far. So if you extend this out, NCAT has done analysis and implore you to kind of look at those resources to see that specific analysis. But this has huge life cycle benefits on this life extension that you're getting out of this. And this is the proof in the pudding, right? This is showing that by taking a purely volumetric design and designing more with balanced mix design in mind, you can make significant performance improvements. And imagine that throughout your system. So we highlight the why here and try and hit on it hard because we have had experience with those in certain areas that maybe haven't coalesced what's their why. Understood, probably improved performance is the same for everybody, but there's very specific ways that we've talked to different agencies, different areas, and their why is slightly different. And in order to get to a good plan to move forward to implementation, it's important to know your why. Why are you going to do this? How are you going to justify this to people that want, why are you doing this? Okay, so that's a really important thing that you have to do in order to even get to the planning that Tim is going to talk about. Other important things that to consider before you start crafting a plan is identifying your resources. And a big thing within those of you, I see we had a lot of people signed in from agencies, is the identification of champions. All right, on the state DOT and the industry side. All right, have somebody that's going to fight for balanced mix design implementation within the area that they work. All right, it's important to have these champions, and we could throw this slide up here for nearly anything, not just balanced mix design, right? But if you have something where it's maybe done a little bit by there's no one really in a point person, it can lose some of that drive, someone who's going to continue to push it forward. So it's important to have that champion, not only at the agency or at the state DOT, but also somebody within industry who's going to help kind of corral things on that end and get industry involved, as we'll talk about with creating the plan. Because it needs to have somebody in that role who's going to have the leadership to look forward and see what's going to be necessary to continue to move this forward, and also handle a lot of the communication, right? That's often where we fall down as engineering or people in that area, kind of that ilk. Continuous communication among those involved and get partnerships where you need it, okay? It's also about identifying external resources and finding what you need. I think we all know that you can't go to an asphalt meeting without hearing about balanced mix design at this point, but that means there's a lot of work going on, work that could help you in your implementation. So that's a lot to keep up with. There are resources available. I work in the Federal Highway Resource Center, and that's our entire kind of job, is to provide that technical assistance. So we're a resource. There's peer exchanges, as this cooperative agreement has been hosting around, and working with your peers, right? Other state agencies that may be near you or similar to you that you can learn from. There's also great external resources, like Tim talked about, the NAPA BMD resource guide. That's where that map comes from. That's an excellent place to go to see what's being done, as well as resources from NCAT, as mentioned earlier. A couple examples of what we've seen for resources as I get close to transferring this to Tim, but resources on the agency side, when identifying champions, we have a couple different examples from those highlighted states that we've continued to talk to. A couple things that I'd highlight here is that a number of the states, you found that they needed to get upper management or leadership support and commitment, especially when it came to acquiring equipment, lab space, staffing, getting pilot projects, right? There's going to be asks that probably need to go up levels to get approved at an agency standpoint or from a state DOT standpoint. Getting that buy-in is going to be important to have those things be successful. Other things we found was something, especially on states, depending on how you're broken up or have different areas, materials, construction, pavement management. New Jersey DOT felt it was very important to make an internal partnership, that not one division, one area of the DOT was going to do this in a silo, because they found it went among all of them. For them, that meant materials, working with pavement design, working with pavement management, all together in a way because it's going to cross all of those. It's going to impact all of this. Is not just a lab thing. It sounds like it's just a lab thing. It's going to impact many areas in pavements. It also takes, coordinating with various stakeholders, as Texas found, as they have, you can imagine, for Texas being such a big state, so many districts, etc., a lot of significant efforts, not only in the research realm, but in the implementation realm. And then Virginia, a good example of, and we'll talk about planning later, but a framework for putting this together and somebody who really pushed this forward. One thing I'd really like to know in the Virginia thing is they have the Virginia Research Council, right? VTRC. And they did a lot of the applied research, but they kept the DOT involved the whole time. It's really important that if somebody's working on this, DOT and the people actually it's going to impact are involved throughout the whole process. And so one other thing we saw from resources from the states we've talked to is many of them have support from academia in some way, shape, or form. All right, so we have examples. Texas is a great one where they have agreement with multiple universities. California, same thing. Again, I gave the example of Illinois and Virginia, same thing. The thing I think that's important to highlight here is that they often have certain parts that they are kind of putting out to research. It's a very big distinction from just giving it to a university and say, implement balanced mix design for me. All right, that we found is less successful. It's more to say, okay, we need help on aging and how we're going to handle that in this given state. That's a research project with a kind of very maybe narrow or precise focus with a problem to answer. Not because no academic institution can necessarily tell a state exactly how to implement it. Also without contractor input, etc. But these states have often found it very successful to work with their academic partners in a lot of different ways to get that support where maybe their own staff can't do it alone. So these are some of the things that's important to think about even before you get to the planning stage. What do I have at my disposal? What help can I have? Why am I doing this in the first place? Not only just from the state agency or whoever you're working for, but also for your industry, your contractors, etc. What's their why? All important before you get to the actual plan. And so with that, I'm going to give it over to Tim to talk about the actual putting together a plan and some excellent examples we've found. Go ahead, Tim.
Okay, thanks, Derek. Yeah, so implementation planning, and then I'll go over 3 examples from state DOTs. And to get started with the planning, you really need to know your goals and scope. What are you looking to get out of balanced mix design? Because that goal and scope really is going to impact the time and complexity, the time it takes to implement and the complexity of your implementation plan. And we'll hear oftentimes of states that we visit, well, there's not enough staff, we're short on staff. Other times we'll hear, well, more testing is a hard sell. It seems like we're already doing a lot of testing. So in looking at this, some things to consider. Do you really want to look at all of your projects statewide, or maybe take a phased approach? A phased approach might look at certain projects. Maybe there's a common type of mixture. Maybe there's a mixture that uses high quantities, and that would be a good place to get started in terms of a phased approach. Another thing that can really impact the complexity of the scope is your goal in terms of mixed design only, or if you look at mixed design and acceptance, and then how often. That can impact the timing quite a bit. We visited many states, and none of them are the same, of course. Some state DOTs have a program of 500,000 tons per year. Some have 20 million tons per year. Some have no Hamburgs right now, and they're looking at purchasing their first. And we go to other states, and they have 6 Hamburgs already going in their central lab. So everybody has different resources. Everybody's at a different level. And so it's really not possible to have one goal and scope nationally. It really depends on the unique situation in each state. And to highlight just a few examples of goal and scope, can share a few examples here. One, for example, is Caltrans. Now, Caltrans, they look at their long life asphalt pavements. These are high traffic projects, very large, 100,000 tons on each individual project itself. They don't do these that often, maybe once every 3 years. And because of the high traffic and the risk of these projects, their goal is to do balanced mix design and also acceptance. Also a feature they have is they're using some mechanistic balanced mix design tests so they can predict pavement performance, actually predict the amount of rutting and cracking. But again, they're not doing these that often. Now, on the other hand, Illinois and Louisiana, they're really looking at trying to get better performance through use of sometimes reclaimed asphalt shingles or reclaimed asphalt pavement. Those recycled materials can be used on all projects. So those states are looking at all projects. So they have a much bigger scope. The start of each of those efforts was in the design. They used a phased approach to implement in design, and they're now statewide implemented, and they're now phasing in the acceptance after that. Maine DOT, they felt like they had a good acceptance program, but they just wanted to get better mixed designs up front. So their initial goal was to use balanced mixed design and just design only on their interstate and high investment projects. When you go that far north, you can imagine the paving season is not that long, and the paving season corresponds to the tourist season. So when they build a project in those high investment areas, they want to make sure those pavements last. And then New Jersey DOT and also Texas DOT were very similar. They started with just 20% of their mixtures. They started with their specialty mixtures. Their specialty mixtures used balanced mix design and gave them some mixtures that were able to go out there and combat reflective cracking or other types of cracking or use high wrap, and really found balanced mix design to be a great tool. Now through a phased implementation approach, they're now looking at all of their dense graded mixes, not only in design, but also acceptance. The other thing I want to point out in terms of the the goals and scope that could make things complex is how the mechanical mixture performance tests, how those balanced mix design performance tests relate to mixed design and acceptance. Now, in mixed design, more often than not, the contractor has the responsibility of developing that mixed design, oftentimes in the lab, but not always. And then the agency has to approve the job mix formula. Now, there's different trade-offs here. Some agencies do a lab mix sample to approve a job mix formula. Some agencies use paper review to approve a job mix formula and wait till they get over there to box D, where initial production is, to verify that mixed design based on what comes out of the plant. Looking at that first representative sample, a control strip, or even requiring a contractor to do a trial hot drop prior to placing material on a project, an agency can then verify that mix with plant produced material. Or as you move to the box E, where you're looking at acceptance, we're going out through the full course of production. How are balanced mix design tests handled there? Perhaps just go, no go. We've seen frequencies of 6,000 tons to 10,000 tons. Maybe the tests are long and somewhat complicated, so surrogate tests have been implemented by some states, or even going so far as to apply pay factors to balance mix design. But the goal and scope, timing, and complexity is going to vary greatly in terms of some of these initial discussions you have about mixed design and acceptance. So establishing that goal in terms of the complexity of planning, if you look at mixed design approval, mixed design verification, or acceptance as defined in that last slide, there's a lot of questions that come up. Whose responsibility is the mixed design and that performance testing? Is the state going to accept contractor results for performance tests? And if so, that's going to enter into a whole new realm of requirements, including verification and validation. How's the state going to verify and accept mixed designs from the lab mix samples, from plant mixed at the initial start? How do you plan for additional workload, costs, and time involved? Regardless of how you answer any of those questions, there is going to be some additional time. The central lab usually handles a lot of that, but also the district or region lab can certainly get involved at various points, either in the mixed design or production. And how's production testing going to be handled and at what frequency? Of course, not all tests pass. From time to time, there will be a failing test. How are those handled? And then that leads us to dispute resolution and even the skilled workforce that's necessary. Sometimes people are used to running those asphalt content and gradation tests, and all of a sudden, these tests are much more complicated, even than the typical volumetric tests. So these things are good to have a handle on. A final decision doesn't have to be made, but the time and complexity it takes to go through your implementation plan is going to impact a lot of these discussions. And these discussions are great to have with stakeholders and task forces. The questions are a lot of critical issues. What's the state's perspective? What's the industry perspective? Well, having a strong champion to lead through those discussions in order to come up with some initial direction to set a plan is important. A couple examples here. One is from Illinois DOT. They had an implementation task force. It was a joint task force between agency, industry, and also the academia. Virginia DOT, they had two task forces. So they had a technical subcommittee. So all those technical issues, how do you handle recycling agents? What do we do for long-term aging? The technical subcommittee handled all of those type issues, while a higher level BMD task force looked more at management issues. Well, we might need some more equipment. How much equipment, how much funding do we have to find? What about workforce and training? The management type questions were handled by a higher level task force. So then when some of these initial questions are answered, mapping the tasks is a great place to proceed. You have a lot of issues on the table, and with the agency, contractors, and other stakeholders, how are you going to address those issues? Sometimes you might want to write a research problem statement specifically to an issue, and then academia can take charge and provide an answer. Sometimes other states have encountered that situation, and you can rely on what other states did to a certain point to see how it could be implemented within your area. And examples might include round robin studies or validation. In fact, these are two very key ones. When we had a lead state meeting, the lead states told us that those round robin studies, getting reproducibility between two labs is going to take much longer than they ever anticipated. So start round robins early. Likewise with validation, you're going to need that to set criteria. And as Derek often says, when's the best time to start validation? That would be yesterday. So you don't have to stress too much with answers to all of these questions, but you need to have an idea to develop a plan. And keep in mind that the plan is the point at which you begin deviation. The plan will change, I can assure you of that, but at least having that initial plan outlined will help. So now I'm going to go over 3 examples from state DOTs, and we'll start with Virginia. So with all of those questions out there, industry's asking them, state people are asking them, you keep the big picture in mind, and they mapped the task. They were going to select their BMD approach. Was it going to be approach A, B, C, or D? Get an idea there. Evaluate many performance tests. They looked at a lot of them to see which one might fit best for the situation in Virginia, and then they selected a performance test. They honed into the test procedure because they wanted to make sure they could get repeatable results. They ran some interlab studies or round robins to make sure testing was going smoothly. And then they developed some initial performance criteria just to get an idea for their benchmarking and pilot projects, where they were at and what could happen. But they knew to tie that criteria down, they needed to do validation. And so validation occurred throughout the states to really set that criteria that they could put in a specification. And through validation, they picked the actual criteria and wrote their acceptance. So that's a good way to develop a big picture mapping. And then they put timelines on that. And the timelines were to develop the lab testing specifications, purchase lab equipment. They're going to build some pilot projects. They had a few research projects in mind they needed to get completed. And then they would head towards statewide implementation. Now, we visited Virginia in 2020, and at that time, they showed us this plan, and they told us it was a very aggressive plan. And quite honestly, with what they told me in terms of what they had done and where they were headed, I thought it was an overly aggressive plan. I thought, oh my gosh, I wish them the best, but I'm just not sure that they're going to have enough time in there. Now, keeping in mind that from the beginning, they wanted to phase in implementation. They were they were not just going to go to statewide implementation on all the mix throughout the state. They were going to have some kind of phasing. Well, I think this plan really is a strong or powerful indicator of planning with timelines and how it can be a powerful motivator. So let's take a look at what actually happened. So as they got going, they advanced from 10 projects to 13 projects to 15 projects. They advanced from 72,000 tons per year to over 300,000 tons per year. They started with 5 districts being involved to 9 districts being involved. And then last year, they focused on their phased implementation with their non-polymer dense graded surface mix. And for their approach A, which was the performance tests and mix design only, was about 700,000 tons. And for their approach D, which was for using performance tests for mix design and acceptance, they were about 1.5 million tons. So by having this plan in 5 years, essentially, they had reached implementation of a significant part of their program. It really shows the power of having a plan and setting target dates. In fact, when we met with our lead states, one of the feedbacks they gave us is you have to have a plan if you're going to advance, and it's best to write that plan down. So the second example I'll go over is from Illinois. In Illinois, their initial plan, I'll highlight, is about 5 years. As that shows that it does take significant effort over a long period of time, keeping in mind they had already implemented the Hamburg wheel track test. So this was just to implement the cracking test. They're just trying to implement cracking only. Initially, this is what they thought. So we'll take a look once they got full implementation. This is where they finally ended up. It was about 10 years. Now, keeping in mind, they started very early in the process. There were not very many standard test procedures for cracking, so they had to develop their own cracking test. I think now as you get going, people would say there's more than enough test procedures for cracking. The other thing was long-term aging. They knew that was important, and there was really no standard procedure or standard practice for long-term aging. They had to develop their own, but now I think you would say there's more than ample long-term aging practices out there. But they had to start early on from scratch, and it took about 10 years to get to acceptance. Now, when we met with the lead states, one of the feedbacks they gave us was to keep these plans updated. The plan you start with is not the plan you're going to end up with. Keep it updated, especially by documenting decisions, because by the time you get to implementation, over that much time, key people may retire, key people may switch jobs. And at this point in time, they want to go back and identify some tweaks here or some adjustments there. And it's going to be very important for them to have that background information to do things effectively. And the third example comes from Texas DOT. Here, they're using the 8 tasks from the FHWA tech brief, and Derek highlighted that early on in his presentation there. And what they do is they identify the 8 tasks in a column. They have some notes related to those 8 tasks, the status, and then a timeline or a completion timeline. And so you can see for task 2, overall planning, goals, tasks, and timelines, they've highlighted that in green as complete. Sometimes they're in orange is an ongoing. For example, in task 3, validation, that's listed as ongoing. So they've built the validation sections. They're going out now annually and measuring performance so they can compare the test results versus the actual field performance. Or when you go down to task 7, the training and accreditation, they recognize they're going to have to do that and get that going, but it's highlighted in red as being not started, but it has a completion date target of 2026. Now you can imagine in Texas, there's a lot of people key in their headquarter materials and constructions that want to know what's going on, but they have 25 districts, and each district has materials and construction people, and they want to know what's going on as well. And along with that, there's contractors that are bidding on projects, and they want to know what's happening, where are we at, what is the latest information. So this was an excellent communication tool that TxDOT could use to let all of these stakeholders know. In fact, when we met with our lead states, one of the comments from a lead state was there's likely better skill sets at planning and scheduling than those that are in materials. For example, in construction, there's people that analyze project schedules all the time. For example, when contractors file a claim for a delay, is it really a delay? Is it on the critical path? And the lead states encouraged us to pass along to take advantage of other skill sets that may exist throughout the agency. And I can say one project I'm working on, the team has a rocket scientist doing the project scheduling, and it makes the effort of tracking all the tasks a lot easier on my side. So take advantage of those skill sets. So implementation planning and examples. And with that, I'm going to turn it back to Derek for effective practices and lessons learned.
Thanks, Tim. So as we're approaching the end of the webinar or end of the slides, and then we'll open up for questions. And as Ellie has added in the chat, please make sure that if you have any questions, you can add them in the chat as we're going, and we'll answer them at the end. I'm going to summarize kind of what we've seen overall and share some effective practices and what we've learned from all this to date. So Tim mentioned lead states. So we actually did a peer exchange with some of we identified as the lead states around the country that are a little bit ahead on balanced mix design. Had some very important thoughts. I want to take some time and really go through these. So we've categorized them into two places. Number one, to support planning, and then the planning itself, much like we talked about earlier. So in order to support the planning, you know, Tim highlighted starting an agency industry working, whether it's something that's built off of a working group that you may have, but we find often that it should be dedicated to balanced mix design, not just another agenda topic on your typical specification committee or whatever that is, right? If it's dedicated, then things will happen. Again, consider what works for you. Tim highlighted the Virginia example where they had kind of a parent committee that dealt in the larger items and then had more of a technical subcommittee. Document your motivations and your goals. Why are you doing this? I'll hit this again later. Everyone should be able to answer that pretty easily. Why are we doing this? Why are we expending these resources, etc.? So the way to really do that is to document them. Here's what we think balanced mix design will look like for us. Here's our motivation and what we aim to get out of it. Making progress by meeting regularly with internal stakeholders. Again, the idea that one given area of your agency or your DOT probably cannot do balanced mix design all on their own, as it's most likely to cross into multiple. So again, having some sort of regular meeting. I had someone teach me before the idea that scheduled things happen, unscheduled things don't. Right. So if balanced mix design is something that you're just working on the side, other things are going to get in the way, right? Other things, there's always an emergency to deal with. If it's important enough, schedule these and have them regularly to have progress if you want to make real progress. Again, document the why behind the specifications, the options. And I like what Tim said, that that's a living document. Again, it's likely that implementation of balanced mix design is going to take enough time where at least someone who's key on the team is going to move to a different job or retire or something along those lines. If the answers to all those questions about why you decided to do XYZ are in somebody's head, not going to be very easy to defend it on in the future. Take advantage of training and education. For a certain sect of us, it probably feels like you maybe feel nauseous. Oh, here's Derek talking about balanced mix design again, right? But there's probably a lot of people in your state that don't have that experience, that haven't had a ton of training and education on this topic. So consider ways to get awareness level up. Remember, a lot of us are in that area where the unknown is scary, right? And this is unknown. So a way to get people on board with it or more comfortable to talk about moving towards balanced mix design, if that's your goal, is to educate everybody on this, right? Also, consider specific items like a BMD implementation workshop. It's something that we continue to offer through Federal Highway. We are actually at the point where we've done over 20 of these. We're actually doing them in a couple states where we already held a virtual version, where we did them virtually during COVID years for only virtually, and then we've started doing them in person. We've actually are hitting a couple states where we had done previously. We found these are very useful because they're done to not only state DOT or agency personnel, but also with your contractors, so you can have those meaningful discussions in the room, right? And then build upon those, as Tim talked about, with discussions about at least getting to the point is, how does everybody feel? What are people's thoughts on this, even if you can't get to it? And then an important thing to think about to support planning is that I've used this analogy before, that balanced mix design is probably not going to be something where confetti falls from the ceiling and a mission accomplished banner is there behind you and everything like that, and you'll never think about it again. Balanced mix design really is hopefully something that you set up and you monitor and update, right, along with your plan, that it will always continually evolve over time and hopefully get to the point where you're evolving along. Whereas contrast this with maybe with more of what our industry has done largely since SuperPave, right? We've acknowledged some of the problems with SuperPave. We've been trying to make adjustments, but kind of still relying on something to get us performance. So monitor that plan, update your progress, and your goals and all that, as Tim talked about, may change over time. That's fine, but keep it updated. So when actually doing the planning, what did lead states kind of talk about as, again, some ideas, some lessons learned? It's create a plan, even if it's an estimate, even if it's a couple pages, a page or two, it's something, right? It's something that can be shared with stakeholders. It can evolve over time. Again, I think people get maybe a little bit nervous about committing to a schedule, and understood something that may be years off, but you can put enough disclaimers on this. This is what we're anticipating as of this time. And then you update it every year to say, okay, maybe we haven't made enough progress. Maybe we're pushing out, etc. Given that, also evolve the plan with well-defined milestones, all right? This helps in a number of ways. Number one, with resource allocation, right? If it's just something that you're going to do eventually, why are you going to dedicate resources to that, right? Whereas if you have some sort of deadline, it's also something that's going to has a lot of tasks and things to happen, right? So those, just think about it psychologically. It feels a little, may feel a little down that I haven't made any progress. The goal is still so far away, right? But what if I have an interim milestone? We can start making some progress. We figured something out. We have a plan for validation. We have a validation site or two, or whatever it is. You're now making progress on key milestones. Emphasize clear but realistic tasks and timelines, right? This is often an add-on. I think we often see from the lead states as well that BMD often a lot of times is going to be more work in the short term. It has those huge benefits that we talked about. So there is something to be paid for that. As Tim talked about, we have tools like the 8 tasks and things like that, and we have some of those schedules. Think about getting support for the development of a Gantt chart or something more, more robust than what we may just be put together. Again, we work in the pavement world. There are people and experts in that area that could help with that. Again, update and adjust the plan regularly at some frequency. Again, document why things may have changed, right? Our goal was mixed design only, and we've now decided that we think we need to do some sort of production testing. Well, why? Why did that change, right? Well, we were going to do X aging process, and now we've changed to another one. Why? Why was that change made? The value of that cannot be understated, given the amount of time, the little amount of time it takes to document those things. For people that come down the line from you, you're going to very much benefit from that. Again, you can use the plan as a communication tool for any stakeholders, that be external to the DOT, things like industry. Also, management. Why are we spending time and resources on this, etc.? That can be that, and here's our plan as a tool. And then leverage whatever research programs you have as a resource. If there's specific problems that they can assist with and get you support, that's certainly an avenue as well. These are some of those things that those lead states, those that either have a BMD spec today or are very close to it, all kind of talked about. It's not something you do overnight, right? And it takes some serious planning in order to, avoid some pitfalls. So as far as takeaways, I pose these questions to you from those in different states that may be in different places with how you're considering balanced mix design and maybe working towards it one way or another. I would challenge you to ask yourself these questions. Do you have answers to these questions? Even as of right now, could be the considered draft answers to the questions. They can change. Remember, as Tim said, as soon as you make a plan, now you start deviating, right? They can change, but do you have an answer that maybe you think that multiple people in your state or area would give the same answer, right? Questions like, why are we moving to balanced mix design? How will it benefit all the parties, not just the state DOT or the agency, but also contractors? What type of projects will balanced mix design be used on, even initially? Is it going to be everywhere? Low traffic, high traffic, whatever, right? How will it be phased in? Are we going to go from no balanced mix design to all balanced mix design overnight? Okay. What does an implemented balanced mix design look like for us? At least an initial phase. Is it mixed design only? Does it go beyond that? Is it mixed design only for a certain category of projects? Again, there's many ways that you can kind of phase in implementation of balanced mix design. Very few agencies are at the kind of all mixes level or looking at the all mixes level. Well, what makes sense for you? It's going to be a little bit different state to state, agency to agency. And how are we working together? How are we going to get this done? How are we going to work with industry internally, et cetera? I think these are good kind of gut check questions to ask yourself. If it's hard to come up with these answers, or at least what your current thinking, your current plan, you know, if you're getting a variety of answers when you think through this in your head from your state, or you don't know, probably an idea to do some more formal planning, because maybe all of this hasn't necessarily been thought out. And again, I think that the message from the lead states and others is that this will save you time. You know, any sort of planning and keeping it up to date over time will save you time and resources as you go through anything like this, balanced mix design or anything else that is significant and is going to take a significant amount of time in order to put into place. So with that, that's our kind of topic on the planning topic. At least I'll go on and highlight our upcoming webinars as we get close to questions. So continue to put those in the chat. Our webinar today was on planning for implementation, right? Planning to succeed. Our future ones, which are going to be basically every month from now until June. Next month, we'll be hitting the key topic we talked about a lot today, validation. All right. It's one of, I would consider, a critical path item on your planning to think about how you're going to do that, how you're going to get to criteria, et cetera. We'll also have one after that on fabrication and, you know, production procedures of specimens. How are specimens fabricated in the lab? How it impacts results. Then we'll have one on testing conditions, and you can read about that as aging, test temperature, all those things, making sure that fits your condition and works for your for what you're looking for. And then finally, we'll talk about kind of the new frontier with balanced mix design in our fifth one about what does balanced mix design mean for quality assurance and bringing it into the quality assurance environment. What do we know? What things are considered there? And so finally, an advertisement for Federal Highways Balanced Mix Design website, where we have a lot of our cooperative agreement materials, the peer exchange reports, the individual state reports. A lot of the material that we've cited is there. We also have the QR code to think about a balanced mix design workshop, which again, we continue to offer for agencies and their stakeholders across the country, both in person and virtual, right? And a lot of resources are out there that we hope that we can help, as well as we hope these webinars really are answering some of the key questions that you all have. And so with that, I'll turn it back to Ellie, and appreciate everyone listening and happy to answer any questions.
Well, thank you, Derek, and thank you, Tim, for the great informational presentations. We do have a list of questions. We'll try to tackle them as much as we can within the remaining 25 minutes that we have on our schedule. So let me start with the first one is, how important is it to document the BMD implementation plan? And what is the level of detail required for effective documentation?
You want to go first, Tim, or you want me
to? Yeah, go ahead, Derek.
Yeah. So I think, you know, level of documentation probably depends on where you're at. I think if you're in the very initial stages, you may not be able to answer a lot of those questions. But I think even if you have leanings, I think that's important to document, right? Is right now we're thinking about staying with mixed design only on interstates, right? And we're thinking this for validation and these tests, etc. I don't think it needs to be a 40-page document to be effective, right? I think it's that there's agreement on it. It's been talked about. I think that will grow in detail and size as you progress, right? As you progress, I think it's only going to grow in size because you've done more. You've made more decisions. You've learned more, and it's changed over time. So I know that's not terribly specific, but I don't think it needs to follow a necessary form. I think what makes it work for you and that it's more something that you add to over time. So I think if you're early, I think it'd be pretty concise. I think the discussions that you have will probably be more extensive than the document itself, if that makes sense.
Very good. Thank you, Derek. So our next question is, has there been any discussions around how to link the BMD to the binder, like the M320 grading? Since the goal is, for both is superior performing pavements, could integrating BMD and M320 be beneficial? So in other words, some asphalt binder testing along with the balanced mix design.
Yeah, I could briefly, I'd say in all of the states we visited, when you go to a balanced mix design, when you're using a mechanical mixture performance test, you're testing the mixture, but nevertheless, virtually all of those states have kept their PG binder grading specifications. So M320 is that sharp or that super pave PG binder grade, like a PG 64 minus 22, what have you. It's very rare exceptions that we see people just rely on the balanced mix design test only. And the one rare exception I can think of would be New Jersey DOT, and they do not specify a PG grade, but you have to look at the balanced mix design tests they're doing. They're doing some very rigorous testing with the overlay tester and even the flexural bending beam fatigue. And they have some very strict criteria such that they know in advance the contractors are likely going to have to use polymer modification and even highly polymer modified. But I would certainly, when you get started, I'd certainly keep the M320 in there.
I just want to add real quick, Elliot, that I think, certainly we know that the binder's impact on the mixture is huge, right? However, if just a good binder spec got us good performance, we're probably not talking about BMD either, right? So they do work together, right? I think you need a good binder in order to get good mixture performance, but it's not a guarantee, right? And I think the other thing that we found through BMD that at least the binder spec as of today doesn't discriminate, right? That the same 64 minus 22 gives vastly different BMD. Now, the idea is that maybe there are more discriminating binder tests out there, but I still think you kind of need, I think the binder is more of a purchase specification and the mixes end up the product that you end up with. So I think you need a good binder and you need certainly specifications there. That's a key part of this, but it doesn't give you that guarantee, and that's where BMD is trying to get into.
Very good. Our next questions is related to the BMD test acceptance criteria, and if those were developed based on mixtures that meet specific volumetric requirements, would those criteria, BMD test criteria, needs to be modified, especially when start using different type of innovative materials like recycling agents, polymers, and so forth?
Yeah, I guess a couple thoughts on this, Ellie. It's an excellent point. Using criteria derived, if you're planning to derive criteria from, current super paved dense graded mixtures, and then you plan to relax a bunch of specs that allow things outside of that, you're extrapolating, right? And saying that criteria is going to work for those other things. So I think this is something more to consider, certainly in planning, but I think this goes to our next topic, which is going to be on validation, that you want to set up your validation. So hopefully it handle this type of thing. So it's kind of thinking about what relaxation you would allow, maybe allowing innovative material, and make sure the BMD criteria that you select and the test you select actually handles that material and is able to discern what performs and what doesn't.
Yeah, that very good, Derek. And I would just add to foreshadow to next month's validation topic. A key acronym we use is RAP. Normally people think about it as reclaimed asphalt pavement, but in validation, we research the validation efforts that are out there, assess whether those validation efforts apply to you or not. But then in all cases, P is to plan your own validation studies. And with the question here with recycling agents and warm mix additives and biobinders, you may find some validation studies for the test you're selecting on that, but I doubt it will be very thorough as you assess it. And so certainly, as Derek said, you want to plan your own. And I think that acronym of RAP and validation will be a key we'll hit on next time, and maybe with a few other questions coming up as well.
Yeah, you're very good. Thank you, Tim. And just for the records, that next webinar is on validation for BMD, why it's important and how to do it, is on March 4, 2025. And maybe the next question is along the same probably line, is related, is, again, with the use of the polymer modified mixes, how important becomes the selection of the appropriate test to properly capture the effects of polymer modification?
Yeah, I think, any particular category, I know there's a lot of people that are concerned about getting polymer modification, and there's concerns that certain tests, may not capture that. Again, I think this is going to hit on two of our future webinars. So you guys are doing a great job of allowing me to publicize our future ones. But validation for sure, as we just discussed, same concept. But the other one that I'd add is that testing conditions one. You want to make sure that your testing is indicative of your actual conditions. So again, be that aging, be that test temperature, whatever the case, just because somebody found that polymer doesn't show up in one case, in one state, in one testing condition, you got to acknowledge the differences maybe between that and what you have. So to acknowledge, again, I always pick on Arizona. Arizona and where I live in Maine are different planets as far as I'm considered, right? As far as I'm, thinking about it. So again, there's some real differences that may be why you don't see differences here, but you may see differences elsewhere.
And then, Derek, since you talked about the testing conditions, then some states or some agencies still rely on either a Marshall or a beam mix design methods, where the 4-inch diameter specimens are being used. And then the question becomes now, because most of the BMD test uses a 6-inch diameter specimens, how applicable those tests would be with the smaller specimen sizes.
So as far as I'm aware, I know there are some that are looking into this about using 4-inch specimens that are, again, same basic situation, that using Marshall, and they want to see how indicative this is. I think comparing them, if you do go forward with that, right, I think that you're not going to be able to compare those numbers, right? I think that's understood right off the bat, right? Any numbers with 6 will not compare to numbers with 4. It really is almost a different test at that point. So consider that there is work going on in that area, but I would, not a lot, because most are using the 6 inches. But I would almost think it's almost like a different test at that point, that any numbers that you see are going to be, you got to take with a big, grain of salt, if you will.
Yeah, and as Derek said, there are some states looking at that, so it's not uncalled for, but those states are being very careful to assess all these other studies out there, but then plan all their own studies to see what the results are. And I think in least a couple of states I've seen, that we've seen that there has been some successes, but you just have to be very careful about doing your own studies.
Right. Thank you. Thank you, Tim and Derek. I think also there's a very good reference that was added in the box that looked into the comparisons for the ideal CT and ideal RT test between 4 and 6 inches. And also I can just speak a little bit about Nevada DOT also, because they use a beam mix design and they are looking into the ideal CT with the 4 inches. And I can tell you a couple things. One, to reemphasize what you mentioned, that the 4 and the 6 inches will give you different results, obviously. But also the variability is something that you have to keep in mind, especially when you're dealing with a larger nominal maximum aggregate size. On a 4-inch specimen, you're going to see your variability being much higher than on the 6 inches diameter specimen. So that's also something to keep in mind, is the test variability.
And just to add one last thing on there, Ellie, I know Travis Welbeck of NCAT also added, some are looking at different thickness specimens for the BMD test. I think that all goes into that testing condition. So again, I think, the devil's in the details when you're looking at anyone else's work, right? Whether it's from another state or something like that, that you want to ensure that you're looking at, understand exactly how they did their testing. And some of this stuff is obvious. It seems kind of obvious, the size of the specimen. But even we're going to talk about in specimen fabrication, number 3, right? Webinar number 3, we're going to talk about how that has significant impact on any of those results. So I think it's kind of having a healthy skepticism, right? And just wanting to understand truly how others generated their results, because a lot of these things will mean differences.
Yes, absolutely. And the compaction methods, one of the other things that we're looking at over here, that's for sure. Very good. So a lot of good discussions, obviously. I want to take us back a little bit to the implementation plan. And then one of the questions is about having some templates or a suggested template for an implementation plan. Is there something that maybe you can refer to, or?
Sure. Yeah, in fact, it mentions Texas DOT. So when we came up with the 8 tasks, interestingly enough, Amy Epps Martin at Texas A&M Transportation Institute, she took those and put them in an Excel spreadsheet. I thought it was very creative. And sure enough, as we go around doing our balanced mix design implementation workshops, we ask state DOTs, we give them a copy of that Excel spreadsheet, and then we ask them if they could fill it out so we know where they're at. And many of them have started adopting it. So there is a Excel template that we have available, and not sure the best way to get that out, but certainly something that we can share.
Yeah, maybe we can post that on the, at least on the UNR website. Maybe we can have it or advertise that or market it through the LinkedIn.
Sure. Yeah. So it's one thing to look at what other states are doing and try to use that information to make your efforts easier. And I think that's a great tool.
Very good. Thank you. Thank you, Tim. Another question over here is related also to the implementations, and I believe it was you both talked about some phasing in the implementation, like the Virginia example and so forth. But have any states implemented BMD in phases in terms of the tests themselves? For example, starting with the rotting test and then following with the cracking test, or they have both? Typically has to go simultaneously.
Yeah, briefly, I think what we've commonly seen when people implement in a phased approach, test 1 and then go to test 2, we've seen people start with the rutting or moisture damage test. I think Texas started with the Hamburg initially. Then after several years, they started exploring a cracking test. That was similar to what Illinois did. They implemented the Hamburg first, and then they started exploring their cracking test. Also, Louisiana, they've been doing the Hamburg for a long time. After doing it for 5 or so years, then they started implementing their cracking test. So that's another approach, phasing in test 1 to get comfortable and then phasing in test 2. The caution I would offer would be when, like with the Hamburg, how do you get it to pass? You make it stiffer. Well, then just because it passes a rutting test doesn't mean it's going to give you a great mix, because then it may be more likely to crack. So there is a caution there, but even with that caution, I think some people have been careful enough to go down that path successfully.
Yeah, just to reemphasize that point, right? Where we've seen that happen when the Hamburg or something like that was implemented, right? They did not do a lot of relaxation based upon just that, right? Because they only had one side of the flexibility, if you will, equation, right? Stiffness and flexibility, we want both, right? In a very generalized sense. So as soon as they implemented just one side, they did not take a lot of relaxation in their existing spec, because then that could just drive it again just to that one side and almost make things stiffer, make things worse. So you can certainly start on one, especially and often if you have, let's say, not a lot of rutting issues in your state and you have stiffer mixes, it'd probably be easier, a lot faster. You'll go through the 8 tasks maybe faster on the rutting side than you will on the cracking side. So yeah, they don't necessarily need to come in at the same time. It's just, what do you do about relaxation? You probably kind of wait on some of those things until you have your different distresses handled.
Very good point. Thank you, Derek and Tim. The next question, I think you guys touched on that, but I'll bring that up, is basically more about setting the threshold values for any performance test.
Yep.
So yeah, do you want anything you want to add to that?
Yeah, setting thresholds is all about validation, right? It's that our next webinar is really going to cover that, right? You can call anything a rutting test. You can call anything a cracking test. When we talk about validation, and what we're going to talk about next month is making sure that your test actually relates to performance to you in your situation in some way, shape, or form, and then use that relationship to decide what is my acceptable number. Is it 30, 40, 50, whatever it is? So that is really about setting criteria and thresholds. Other things enter into it, right? Where do your mixes stand today? How many mixes would get impacted by the criteria? Those add into it, but you need really that validation in order to get to setting thresholds.
All right, and then maybe one thing to add, Derek, maybe the threshold might be different depending on the mixture application, traffic levels, within the pavement structure. So it doesn't have to be one threshold for all the mixtures.
Right. And I think that brings it back to planning, in the idea that I think acknowledging what are your bins, if you will, right? What are your treatment types, your different expectations? Is traffic a major thing for you, or is it not, right? I have to imagine some states you have a wide range of traffic. Others that I've been to probably don't have as much of a range of traffic. What are your bins where you might have different criteria? Because again, the idea of balanced mix design is to, design and specify for what you're using that mix for. If you do the same and have the same criteria on all your mixes across the state, it's not really accomplishing that, right?
I still have one more question in here, and I still have a few minutes. Does a DOT champion typically come from a specific division within the state DOT? And alternatively, is it necessarily to have a champion from multiple divisions within your state DOT?
I think what we've seen in terms of champions, almost always the agency champion comes from the materials discipline, the pavement and materials discipline. The state materials engineer themselves, or probably the person running the asphalt pavement program, is that champion. Now, it is important, Derek went through the New Jersey example, to coordinate within the multiple disciplines within the agency. For example, pavement management and construction and pavement design, because it will impact many areas. But the agency discipline, I think, has always been the materials person.
Very
good.
And
the only thing I'd add, Tim, there is, I think, it's typically been the materials person, because I think that's the area that's most impacted, right? If you were to kind of rank impact. But I also think a common trait is somebody who can influence or at least have the cachet, if you will, to go to the other divisions and get that tie-in, right? Have that tie-in with industry, et cetera. So I think it typically comes from that area, not necessarily, but I think it also helps for them to have a point of contact in the different areas. So for example, when we've done our workshops, you know, sometimes they've brought somebody from pavement management or a couple key people from construction or whatever divisions they had that they could rely on. And those people aren't going to know the ins and outs of the ideal CT, but they probably need to be aware of what balanced mix design is as a concept and how it's going to benefit and how their work is going to get impacted by this. So I do think they need key ties to other people. Can't be kind of, you know, how something kind of goes by committee and no one stands up for it, right? I think you need someone as a point of contact.
So may not be necessarily a champion, but that communication internally is very important.
Absolutely.
All right, I think we have, we're here toward the end. I know we have a couple of questions, one related to the aging for the ideal CT, and you mentioned that we're gonna touch on that in the upcoming webinar about the testing conditions. And then another one related, I know, Tim, you've been involved with the hamburg wheel tracking test for a while. You did a few presentations and webinars related to the hamburg wheel tracking test. Do you have any backgrounds or information about differences in the test results between the steel wheel and the rubber wheel? Have you came across any studies that compare the two?
Yeah, Ellie, no, I have not. I'd say, you know, obviously the Hamburg test, the AASHTO T324, it uses a steel wheel. I know there's new tests coming out there, like maybe resurrecting, if you will, with a rubber wheel that started at Purdue and now is coming out of Mississippi. But I would just go back to the acronym RAP. You have to research what's out there. I can't say that I have validation information on that. You have to assess how applicable it is to your condition, but certainly plan your own validation. If you're going to modify a test or come up with your own test, then you should have your own validation sections to come up with criteria.
Very good. Thank you, Tim. Thank you, Derek, for the excellent presentation and answers. We appreciate your time and appreciate everybody's time here with us. We would like to ask you to take a few minutes to give us your feedback at the link provided in the chat box. If you can, please let us know. We value your feedback so that we can do better the next time. And then hopefully we'll get to see you again in a month, in about a month. So we have one webinar every month from now till June, before the construction season starts. Thank you, everyone.
Thank you.
Hey, thanks, everybody.